This HackerRank challenge is called Tree Preorder Traversal. This is under the HackerRank data structures problems, and it's about tree traversal. Here we are using the pre-order methods, meaning that as we traverse the tree, we are going to visit the root nodes, then the left child, and then the right child. So here I have an illustration. We're going to start here. This is the root nodes. And then because I said it's root, left, and then right, we're going to visit the left child of that root. So we're going to jump here, and here there's nothing because this is empty. There is no nodes. So in our program, this left child would be pointing to null. So we return from here, and then we go on to visit the right nodes. Before I proceed with the rest of the illustration, I want to show you guys the implementation of their node class. So here we have public as the access specifier, and then we have an attribute called data. This is an int. So this is what we need to print, because in this HackerRank challenge, what we have to do is traverse the tree and then print the data in every node. So here we have two pointers, the left child and the right child. They are both node pointers, and inside the constructor, both pointers are set to null. So back to our program, that's why I said that when we visited the left child here and there was nothing, it was pointing to null. So from here, we jump back and we visit the right child, which is this one. So we print 2, because at first we printed 1, there was nothing on the left. So we move to the right child and we printed the data inside that node, which is 2. And we go on to repeat that process. So we move here, the left child is null. So we return and we visit the right child, which is this one here, and we print 5. Now we can visit the left child. This left child is not null, so we can print the data, and we don't jump directly to 6. We go on to visit the left child of that node here, which is this one here. There is nothing. There is no child node, because this, again, like I said, that left pointer would be pointing to null. So we return from here and we visit the right child. So we are at the leaf node right now with the data of 4. So we return from here, we move on to 3. We are done with that tree here. So we jump up, we go back to 5, and we were not done with that node. So we go on and visit the right child, which is this one, and we can print 6. So after visiting the full tree, our data will be printed in that order: 1, 2, 5, 3, 4, and then 6. So again, 1 to 5, 3, 4, 6. If I check their sample output here, which is the correct result for that sample inputs, they have the same result. They have 1 to 5, 3, 4, 6, just like we did. So this is the solution. It's a function called preorder, and it has a node pointer as a parameter. And what we want to do first is check if that root node is not null. If it's not, then we proceed and print the data of that node. And then we move on to the left child. We initiate a new function call. So we'll go here, back at the top, and we verify if that left child is not null. If it's not, then we go on and print the data in that left child. And we proceed until we are done. And then we move on to the right child nodes inside our tree. And we print also the data from these right child nodes. Anyway, for now, I'm going to run this code. This is in C++. And we've passed both sample test case 0 and sample test case 1. Now I'm going to submit this code. And we've passed all the test cases. So we can also grab this, copy it, move over to C. They are using a struct. So I'm just going to paste this here, clean this up a little bit. I've just replaced the cout statement that we had in C++ with this printf statement right here. But I'm going to add a space because the data needs to be printed with spaces. So now let's run this code here. And we've also passed the sample test cases. I'm submitting the code now, and we've also passed. So that's it, guys, for this HackerRank challenge. If you liked my video, please subscribe to my channel to support it. Turn on your notifications, and I'll catch you next time.